Hello, welcome to another rendition of Wenzel Creations. We are going to be talking about algebraic expressions today, so let's write that down. Algebraic expressions. I know some of you have been excited to start the algebra unit because you know something about it, and others of you have no idea what people are talking about when they talk about algebra. But really, it's just a slightly different language than what you've been used to, but you have all the skills to do it. So just trust me there. Today is about vocabulary, so that when you see an algebraic expression, it really makes sense to you. So I'm going to write down an algebraic expression as an example, and then we're going to copy down some vocab and see if we can identify it. Okay? 2x plus 3 plus y minus 4x. Okay? So there's an example of an algebraic expression. And the reason it's called an algebraic expression is because it involves algebra, which we have some experience knowing that it involves these mystery numbers, x and y, these variables. Okay? First thing I want to ask you when you look at this, and I think you already know this, is what does 2x mean? What does 2x mean? When you write a number right next to a letter like that. Okay? I hope you remember that it means 2 times x. Or I should actually write a little dot so that we don't confuse the x with the multiplication. Okay? So it actually means 2 times x. So anytime you see them directly next to each other, you just assume, you just know that that's a multiplication. Okay? All right, so we got some terminologies. We got the term variables. We got the term terms, terms. We have like terms. We have constants, I think, and we have coefficients. So just copy these down for now. Okay. So all these are just language to talk about these algebraic expressions. So if you don't know the language, you're going to get super confused. Especially like terms, it's going to become really important pretty soon. So it really is important that you practice these, use these frequently. You will in your homework, and learn to they're just normal. It's like talking about an apple. Variables. Okay. So the variables are the letters. Okay, they're the letters. They are the things that have been in your challenges, have been those mystery numbers. Okay. So variables are a letter that represents a number. Okay, the terms. Really, well, actually, let's go back to variables. The letters. What letters do you see here? Okay, I see an X and I see a Y. So this example has two different variables. It may have just been X's and we just write X. Right? The terms are anything, the things added and subtracted. So they're everything in my expression that's being added and subtracted. So I got 2x being added to 3, being added to y, being subtracted, or 4x being subtracted from that. So I actually have 4 of them. Okay? So I have 2x, I have 3, I have y, and I have 4x. Or in this case, it would be negative 4x because it's being subtracted. Okay? Like terms, okay, those are going to be, they have the same. They use the same variable and exponent. Okay, so when I go back up here, I'm looking for things that are like each other, like they have the same letter in it. So for example, 2x and minus 4x, those are going to be like terms because they both have the same variable, the same letter, and I haven't talked about this yet, but they have the same exponent. There is no exponent, right? It's just 1. Okay, so for example, 2x and minus 4x are like terms in this example. Okay? So 3, it does not have a variable, but it's the only thing that doesn't have a variable. So it has no other partner. It has no other like term. Same with y. This is the only time we use y, so it has no other like term. So that's our only sort of pair set of like terms. All right, constants are going to just be the ones that are just numbers. So let's write that. Oh my goodness. Just numbers. Are any of our terms here just numbers? Yep, 3. Okay? So constants are the thing. They're constant because they're not going to change because they don't have an x or y next to them. So once I find out what x and y are, well, it doesn't matter for the constant. It's just going to be that number. It's going to be constantly that number because it's not associated with any of the variables. And then finally, the coefficients are numbers in front of variables. Okay? So the numbers in front of the variables that mean or that are factors that are being multiplied. That are multiplied. Okay, so we have 2 in front of the x here and a -4 in front of the x here. So my coefficients in my example are 2 and -4. So they have to be right next to, they have to be multiplied with a variable. That's what makes it a coefficient. So let's try some examples. Okay, let's try another example here. I got 12 plus 10c plus 1/2. Okay, pause the video here and go through this list and identify if there are variables, terms, like terms, constants, and coefficients in my new example. Pause here and do that. All right, I hope you did that. All right, so my variables are the things with letters. So C is my variable in this case. Okay, so I hope you wrote C is my variable. Terms, things that are being added, subtracted. So I have one term is 12, another term is 10c, a third term is 1/2. So I have 3 different terms. I hope you wrote those down. The like terms have to have the same variable and exponent. Well, this is just a number. This is a factor with factor of 10 multiplied with c, and this is just a number again. So my only things that are like are the ones that are just numbers. So 12 and 1/2 are like terms. Constants, 12 and 1/2 are also constants. They're just numbers. And coefficients are numbers in front of the variables, so just 10 would be that example. All right, let's try the same thing here. Example 2 with 7y plus 12y plus 3x plus 9x. Okay, pause here and go through that process again. All right, if you're coming back, my variables, I have 2, y and x. I have those 2 options in my algebraic expression. Terms, things being added and subtracted. 7y, 12y, 3x, 9x. 4 things, 4 terms. What are like terms? These both have y's, so they're like terms. 7y, 12y are like terms. 3x and 9x are also like terms, okay, because they have the same variable, and that variable, we'll talk about exponents in a second. Constants, anything that's just numbers? No, I have no constants here. Coefficients, numbers in front of the variables? Oh yeah, I got a 7 in front of the variable, 12, 3, and 9, okay? So I hope that's starting to make a little bit more sense. Let's talk about exponents for a bit here. Okay, exponents. Okay, I hope you're remembering some of this, but I'm going to remind you. What if I have 3 repeatedly multiplied? You have a tool to represent repeated multiplication, and it's called exponents. I hope you remember a little bit, but you take that 3 and you count up how many times it's being multiplied together, and that number, 5, is what becomes your exponent. So 3 to the 5th power means 3 times 3 times 3 times 3 times 3. Okay, so 5 times in a row. So then what if I gave you, I replaced that with a variable. So I have d is my variable times d times d times d times d. Now it's like a mystery number. We don't know if it's 3 or not. It's a mystery number, okay? It's the same thing though. It's d, whatever d is, times itself 5 times. So we can represent it like that. All right, so you tell me then, example 1, how would I write this? J times j times j times j times j times j. Do that and then also do example 2. How would I write this? 9 times k times, I'm going to use dots, 9 times k times k times k. Pause here and do that. Okay. For example 1, j is being multiplied by itself 6 times, so your answer should be j to the 6th power. For example 2, you have 9 times k 3 times. So 9 is not a common. We don't know if that's going to be the same as k or it could be different. So I can't combine that into it. I have to keep the 9 out front as my coefficient, and then k to the third power because it's k being multiplied 3 times. So you can start to see how you can simplify math a lot, and you can combine these things to have it make more sense. That's kind of what algebra is doing. It's finding a math language to communicate, you know, something that could be expanded a lot bigger, right? It's saving us some time. So it's 9 times k 3 times, k 3 times, k times k times k. So if you didn't get that, jot that down and make that correction. All right, and then we have this concept called evaluating an expression. So let me give you an example of what I mean. What if you find out what x or y is? For example, okay? All right, I'll call this topic evaluate. Example 1, okay? Evaluate k plus 10 when k equals 25. Okay, so they give us algebraic expression k plus 10, and they even tell us what k equals. So k is no longer a mystery number. Okay, we know k equals 25. All they're asking you to do is put that into your expression and solve it. So k equals 10, and I know that k is 25. I'm not going to write k anymore. I'm going to write 25 plus 10. That's it. All right? What's your solution there then? Your answer is going to be 35. So if you get a question like this, they just want you to put in the mystery number and solve it. There you go. All right, example 2. Evaluate 3x minus 14 when x equals 5. So again, they tell you the mystery number. So the first thing you do is you copy down that expression. Okay? What does 3 written next to an x represent again? Multiplication. So if it helps you, you could actually write it like that. 3 times x minus 14. And since we know x, I don't need to write x. I can write 5. Okay? Order of operations tells me to do this first. So 3 times 5 is 15 minus 14 equals 1. Okay? So that's the basic gist of it. I'll do one more up here. Example 3. P equals 24 and Q equals 8. What is, or evaluate P divided by Q. So evaluate, I guess, is another way to say solve. Now that you know the mystery number, just solve it. So I'm going to put P, 24 in for P, and 8 in for Q. So I'm going to write a 24 divided by 8. Okay? Hopefully you got that. Answer is 3. So evaluate is just another way to say solve. So it's going to feel confusing and overwhelming, but it's not. It's just language, right? So if you practice these terminologies, you're going to feel super comfortable and you're going to think it's quite easy. So good luck.